Hi, this is Ms. Fuhr, and we're going to talk about writing names and formulas for ionic compounds with transitional metals using Roman numerals. Now, so far, we have written ionic compounds, binary ionic compounds, and with polyatomic ions. But one of the things we've skipped is using the transition metals. Here's an example of an ionic compound with transitional metals. CuBr2 and CuBr. Now, both of these, if we were to name them like we have previously been doing, would be called copper bromide. But there's definitely a difference between these two compounds. So we need to do a little extra in order to name these two compounds. One of the reasons is that we know that group 1 is a +1 charge, group 2 is a +2 charge. We always skipped the transition of metals, and then we said group 13 was a +3. One of the reasons is that transition metals can have more than one charge. For example, copper could have a +1 charge, or copper could have a +2 charge. Now, we've got to be able to tell everybody which one of these coppers have a +1 and which one has a +2. To start with, though, we're going to name these just like we previously named all other ionic compounds. We're going to write the name of the metal down. I leave a little extra room before writing the name of the nonmetal. So we write bromine and change the ending to bromide, just like previous. So both of these are going to be copper bromide. But now we need to tell everybody whether this first one is a copper 1, +1, or is whether it's copper +2. The way we're going to do this is we're going to reverse our crisscross like for writing formulas that we did before. So we know that this 2 at the bottom actually came from the charge from copper. And we know the one that's not written behind copper actually comes from the charge of bromine. So this is telling us that copper must have been a +2 charge originally. Now, to show everybody that that copper has a +2 charge, we're going to put a parenthesis and a Roman numeral 2 after the copper. This is called copper 2 bromide. Now, the copper down below, CuBr, they have in there are 1s. So that is coming up here and saying that copper was a +1 and bromine was a -1. Now, when both of these are 1s, we need to be a little more careful because it could have been something like Cu2Br2, and that would make the charges different and make it a +2 and a -2, and it was reduced. So what we need to do is look at the periodic table and say, what is the charge of bromine on the periodic table? Well, bromine comes from group 17, which we know has a charge of -1. So if it has a charge of -1, then this formula must be right. Copper must also have a charge of +1. So now we're going to write a Roman numeral 1 after the copper. So this is copper 1 bromide. Let's try a few more examples. Okay, let's go with iron oxide, and here is another iron oxide. So we're going to write the name first of FeO just like previously. Iron, leave a little extra space, and then oxide. This one also will be iron, leave a little extra space, oxide. Now, I need to know the charge of FeO. So there's 1s down here. Iron must be a +1 if oxygen is a -1. When we look on the periodic table, oxygen comes out of group 16, and oxygen is not a -1. Oxygen is actually a -2. Therefore, iron must also be a +2. So we're going to write a Roman numeral 2 after the oxygen, after the iron, excuse me. Now on the one down below, we switch it. Iron must be a +3, oxygen must be a -2. So after iron, we're going to write the Roman numeral 3. What about MnO 7. MnO7, we have Mn, which is manganese. We're going to leave a little space and put oxide. Now, we're going to do the switching. The 7 becomes the charge of Mn, and the 1 becomes the charge of oxygen. But we know, once again, oxygen is not a -1, it's -2. So this one's 2 times what it originally was. So this one must be 2 times the one it originally was. So we have a Roman numeral 14. So we're going to put X14. So that's a Roman numeral 14. Now, MnO7 actually does not exist as a molecule. It actually exists as an ion, but we will deal with that later on. Okay, let's try just a couple more examples. How about NiCl2? Now we know nickel's a transitional element, so that would be the first thing that would tell us we need to use a Roman numeral. So we write nickel, leave a little space, write chloride. The 2 comes up to nickel, makes it a +2, and the 1 that's not written goes up to chlorine, it's a -1. So we put Roman numeral 2 after nickel. How about some gold? Let's say AuCl3. So Au would be gold, leave a little space, write chloride. Then we're going to switch. The 3 becomes +3, and the 1 that's not written after gold makes chlorine a -1. So we have Roman numeral 3 after gold. How about silver? Silver, AgCl. This would be silver chloride. Now, silver chloride, if we were to write a Roman numeral, these are both 1s, so silver would be a +1, chlorine would be a -1, and since chlorine on the periodic table is actually a -1, we know silver would be a +1. However, we do not write a Roman numeral. Why? We do not write a Roman numeral because there are certain elements that have known charges, and you just have to memorize them. There's only a few. Silver is always a +1. It doesn't have more than that charge. So when we write the name of silver chloride, we don't put silver 1 chloride, because everybody that's familiar with chemistry knows that silver is always a +1. The one other one that I want you to know is zinc. I want you to know that zinc is always a +2. So if I'm writing ZnCl2, I'm simply going to use zinc chloride. I am not going to tell people that it's zinc 2 chloride, because zinc always has a charge of +2. A few options. Besides the transitional metals, lead and tin also have variable charges. Lead can be a +2, or lead can be a +4. Tin can also be a +2 or a +4. So when we're naming substances with lead and tin, we also have to write their names with Roman numerals. So for example, PbO. PbO would be the name of lead, leave a little space, write oxide. We would assume there's 1s down here, so we'd say lead has a +1 and oxygen has a -1. However, if we look on a periodic table, we know oxygen is not a -1, it is a -2, so I also have to multiply this one by 2, making it lead 2 oxide. Okay, let's try tin. Tin, CnCl4. Okay, this would be tin, leave a little space, and we got chloride. The 4 goes up and makes a +4 charge for tin, and over here we get a -1 charge for chlorine. So in this case, we know that tin's charge is a +4. So we're going to put a Roman numeral 4 after tin, which you get by putting a 1 in front of a 5. All right, now let's change it up a little bit and let's write formulas for transitional metals. Okay, so this time we have the name given to us, and what we're going to see is that there is a Roman numeral in the name that they give to us. Okay, so here is our name, copper 1 fluoride, and we need to write the formula. So like before, we take copper and we write what symbol it has. We take fluoride and we write its symbol. Then we cannot look at the periodic table and find the charge of copper because it's in the transition metals and we don't know its charge. That's where the Roman numeral come in. The Roman numeral, remember, doesn't tell us how many coppers, but it tells us that copper has a +1 charge. We look on the periodic table. Fluorine comes from group 17 as a -1 charge. Okay, the +1 and the -1 cancel each other out, so the formula is simply CuF, copper 1 fluoride. Okay, let's do a few more. Let's take lead 2 sulfate, because we also need to be able to do polyatomic ions. So with lead 2 sulfate, we have, I already gave you the symbol, lead 2 sulfate. We have Pb, and that Roman numeral 2 tells us it's a +2. We have sulfate, which comes off our list of polyatomic ions. We know that because it ends in 8. And when you look in that chart, sulfate has a charge of +2. Again, +2 and -2 cancel out. So we have PbSO4. What about iron 3 nitrate? Okay, iron 3 nitrate would be Fe. We know it has a charge of +3 because of the fact that it has a Roman numeral 3. Nitrate of the polyatomic ions is NO3 with a charge of -1. So we need to switch these this time because they don't cancel out. So that means we need 1 iron and we need 3 nitrates. Now we don't want it to look like 33, so we make sure we put parentheses around any polyatomic ion when we need more than 1. So we don't need to write the 1. We put the polyatomic ion in parentheses and put the 3 after it. Iron 3 nitrate, FeNO3 3. Just try a few more examples. What about copper 1 sulfide? Again, copper, sorry about that. I gave you the symbol right away instead of the name. So we know the symbol for copper is Cu. With Roman numeral 1, we know copper has a +1. Sulfide, because it ends in I, we know it's going to come off the periodic table, S, which is in the same group as oxygen, so it has a charge of -2. We're going to switch them. 2 comes down there, 1 comes there, so Cu2S. That is our formula for copper 1 sulfide. Let's try gold 2 chloride. Okay, so gold would be Au. Roman numeral 2 tells it's a +2. Chloride is Cl, gives us a charge of -1. We're going to switch them 1 and 2. So AuCl2. All right, that tells us how to write formulas and how to name transitional metals that need polyatomic ions. Don't forget, you also have to include lead and tin, that you write Roman numerals for them also, and you do not write Roman numerals for zinc and silver.